Hey, welcome back to your favorite technical mathematics class. We're going to talk about multiplication of algebraic expressions. Let's introduce some properties here again for multiplication. Let me grab my pen here. So last time we talked about the commutative law of addition. Now we're going to talk about that commutative law of multiplication. So 2 times 3 is just saying it's the same as 3 times 2. And don't take these properties for granted. Things like operations with matrices with multiplication, for example, a matrix A times a matrix B is not the same necessarily as a matrix B times a matrix A. Okay, but these do work with our real numbers here. Also, the associative property of multiplication, if you got 2 times 3 times 4, that's the same as 2 times 3 times 4. 2 times 12, 24 is the same as 6 times 4, 24. And then finally, the distributive property says if you've got A times the quantity B plus C, then that would be equivalent to A times B plus A times C. For example, if you got 2 times 3 plus 4, that's the same as 2 times 3 plus 2 times 4. 6 plus 8 or 14. If you look at it, well, 3 plus 4 is 7. Isn't 2 times 7 14? Sure is. So this is the old distributive property that everybody loves. So we got here 3 times x is 3x. We're going to use the distributive property. You got 3 times y is 3y. And by the way, what you're doing there is you're multiplying it by a 1. 3 times 1 is 3, and then you just bring one of that x, right? 3 times the 1y, 1 is 3, and then bring one of the y. Here you got negative 4 times the 1x, and negative 4x. You got negative 4 times negative 4 is a positive 16. It's a plus 16 there. Keep going with this distributive property. We got 6 times a. So number 1 here, we got 6a. You got 6 times 2, 12b. You got 6 times negative 7 minus a 42c. Number 2, we got 3ab times 2a. Now, mind you, here we're multiplying the 3 times the 2 first on this. So we got 6, and then you got the a times that a squared, and then you've got the b right there, b. That's the first one. Now we're going to go 3ab times the negative 5bc. So 3 times negative 5, we got the negative 15. We got a's just coming along for the ride. There's no other a. We got the b times the b there, b squared, and then we got just the c. There's number 2. Number 3. Number 3, we got 3s plus 2 times s plus 2t minus s times 7 minus 2t. Distribute that there. We got 3s plus 2 times a 1s is 2s. 2 times that 2 is a positive 4t. Here we got negative 1s, so negative 1 times 7 is negative 7s. Negative s times the negative 2t. Again, this is like a negative 1 right there. So negative 1 times negative 2 is a positive 2. You got the s and the t. Combine any like terms. 3s plus 2s is 5s. Minus 7s is negative 2s. We just got that 4t. Looks like this is a loner, and then a plus 2st. That's the only like terms there were with the s's. Number 4. We've got a binomial times another binomial. Okay, if you've got this situation occurring, what you're doing is you're going to take the x and distribute it to both of them. And you'll see this referred to as FOIL method. So we do first, then we do the outer, and then we do the inner, and then we do the last right there. So we distribute the x through to both of them first, then we do the outer, then we do the negative 2 through to both of them, the inner right there, and then we do the last. So first, outer, inner, my goodness, and last, outer, inner. Gosh, terrible spelling there. Anyways, we got x times x, we got x squared. And then we got, so that's the first one. Now we got the x times the 7. And then we got the negative 2 times the x. And then we got negative 2 times the 7. So we got x squared plus 7x, and then we got a minus 2x, and then we got a minus 14, and then combine your like terms there. X squared plus 5x minus 14. I better clean up some of this. Get my big eraser here. Got a few more here. Okay. Number 5 right there. We got 2x plus 1 times it by 3x minus 2. Again, first, outer, inner, last. So 2x times 3x, we got 6x squared. 2x times negative 2, negative 4x. We got 1 times 3x is positive 3x. And finally, 1 times negative 2, negative 2. Combine any like terms you got. Those are the only ones that are like term there. Or in the middle. Number 6. Now we've got a binomial in front. Times it by a trinomial. We got 3 terms on this one. So we're going to take the 2a through to everybody, and then we're going to take that 3 through to everybody. So 2a times 2a squared, we got 4a cubed. 2a times 3a, we got 6a squared. 2a times negative b, negative 2ab. And now we're going to take the 3 through. So 3 times 2a squared, 6a squared. 3 times 3a, we got 9a. 3 times negative b, negative 3b on that. And then we combine any like terms we got. There's no other a cubes. We got a 6a squared, another 6a squared. So 12a squared. We got negative 2ab. There's no other 2ab. There's no other ab's. Right, this is a loner. Looks like the 9a is a loner. And then finally the minus 3b is also a loner. So there's number 6. Number 7 there, we got a plus 5 quantity squared. So a plus 5 quantity squared means we got 2 of these a plus 5. So you're just running the FOIL method again, distributive property. So we got a times a squared. We got a times the 5 there on the outside. 5a. Now the inner, 5 times a, 5a, and finally 5 times 5. We got the 25. Combine any like terms you got. And similarly for number 8, 2a minus 3b quantity squared. So there's 2 of these. 2a times 2a, 4a squared. 2a times negative 3b, negative 6ab. Negative 3b times 2a, so negative 6, and this is ba, but again you're going to write that ab. And finally negative 3b times negative 3b is a 9b squared. Combine like terms. Negative 6 apple bananas minus in debt more apples bananas. I'm in debt 12 apple bananas. Okay. Alright, so let's look at properties of exponents now. So if you got a to the m times a to the n, that's a to the m plus n. That would be, for example, like 2 squared times 2 to the third is 2 to then you add those, 2 to the fifth. Right? Because why that is, because you got 2 squared, there's 2 of those. You got 2 cubed, 3 of those. So how many 2's you got? 5 of those. Right? Power of a power rule, so a to the m to the m, so that would be an example of 2 squared to the third, for example. You got 3, well, first of all, the rule says if they're right next to each other, multiply them. So 2 to the 6, okay, that's your shortcut. But what does it mean? You got 3 of these 2 squareds. You got 3 of these 2 squareds. So you got 2 times 2, 2 times 2, 2 times 2, 2 to the 6, 6 of those, okay. Similarly, you just kind of keep going. So these rules, if you write them out, that they make sense, right? They're just kind of the rule, the shortcut, if you will. A times b to the m, a to the n, b to the n, and so on. Power of a quotient, quotient rule. And then we'll get into some of these other ones in the next section. Okay, so let's use some of these. A to the third times a to the fourth. So if you got 3 a's multiplied by 4 more a's, you've got 7 a's. You're going to add those up. there's 7 a's. Now this is a power of a power. You're right next to each other. You have 5 sets of those a to the 4ths. So how many do you have? You have 20 of those a's. Multiplying. Third one, so that's 1, 2. Third one here, we've got a to the 3rd b squared, and this is just being multiplied by a squared b to the 4th. So a to the 3rd times a squared. How many a's is that? Same base there, so you add those exponents. There's 5 of those a's. Now b squared times b to the 4th. B to the 6th, add those up, same base. Right, how many bananas you got? You got b squared, you got 2 bananas, you got b to the 4th, you got 4 bananas. How many total bananas? 6 bananas. Fourth one here, 3c squared d to the 5th to the 3rd. So on this one, the first rule you're going to use is you got different things taken to a power. So you got to take a to the n, b to the n as an equivalent form of that. So power of a product rule. So we're going to take 3 to the 3rd, c squared to the 3rd, and d to the 5th to the 3rd. So 3 to the 3rd, 3 times 3 times 3, 27. 3 of those c squared, so you multiply it, power of a power, when they're right next to each other like that, you're going to multiply it. D to the 5th to the 3rd, so d to the 15th. That's number 4. Number 5 here, we've got negative 2x squared y to the 6, and this is all squared. So you're going to take the negative 2 squared, x squared is squared, y to the 6 is squared, negative 2 squared, so negative 2 times negative 2, positive 2, x squared squared, multiply those 2's because they're right next to each other, multiply those, you got y to the 12th. 6, negative x cubed y to the 4th, to the 3rd. Now this is a negative 1 in front, so don't forget that's a negative 1 to the 3rd. You got x to the 3rd to the 3rd, y to the 4th is to the 3rd. So you got negative, multiply those, x to the 9th, multiply those, y 12th. Okay, number 7 there. You got 2ab to the 3rd, this is number 7, times 3a squared bc. 2 times 3, we got 6. A times a squared, 3 of those a's. B cubed times b, there's 4 of those b's. And finally, we got the c on the end. I'm running out of room here. Alright, number 8. We got negative 2x squared y to the 3rd. Boy, my handwriting I think is getting worse here. Sorry about that. Kind of hard with this awkward pen thing I'm using. So we got negative 2 times the 4, we got negative 8. We got that x squared times another x squared, so we got 4 of those x's. And we got y to the 3rd, 3 y's, and another y, y to the 4th. Number 9, second to the bottom there, we got 2ax times 3ax squared. Notice the plus here, so we got to distribute that, plus 5x cubed. So we got 2 times 3, 6, a times a squared, x times x squared, x to the 3rd, plus, because we got a positive 2 times a positive 5, 10. We got x times x cubed, x to the 4th. There's number 9, and then finally number 10. Also notice on the inside here, it's got pluses and minuses. You got 3 different terms, so we're going to have to distribute this. Distribute that. Okay, so negative 5 times 3, negative 15, x times x squared, y, negative 5 times negative 2, 10, x squared times x cubed, we got y times y, y squared, negative 5 times the 4 last term here, negative 20, so minus 20, x squared, that's the only x's here, y times y, y squared. Make sure there's no other like terms, there's no other x squared y's, there's no other x cubed y squares, there's no other x squared y squareds on the end either, so there's nothing to combine. Well, that takes care of this section. Thanks for watching. We will see you next time.